Welcome back. We're going to do the A3 notes today. You might notice it's about polynomials and factoring. You did a lot with factoring in Algebra 2. And so what the objective of this is that we go over these FOILing and factoring properties so that you become a lot more efficient and that you can apply them to things like trigonometry and stuff in the future. So just to go over what a polynomial is, poly meaning many. Nomial numbers, so we're going to have many numbered terms. Here's just a standard format of a polynomial. It kind of looks a lot more mathy than regular. You know, we have all the letters, no numbers. But to get you familiar with this first term, this leading term, it's going to have two things. It's going to tell you your degree. It's going to be n. And the leading coefficient is the number in front of the highest degree term, so that would be a sub n. Keep in mind that this degree is also going to be the biggest number, so that it is, if your polynomial is not in standard form, you might have to rewrite it in standard form in order to find the degree. At the end, you're going to have a constant term. Sometimes they call that c. It's when we have x to the 0 power. If you remember, x to the 0 power is just 1. So our constant term is going to be a sub 0. All right. So when we write these in standard form, you need to have descending powers of x. So if you look at this next example, we need to rewrite that so it has the highest degree first and then all the way down to a constant if there is one. When looking at this, negative 10v to the 11th, that has the highest degree. Keep in mind that when you rewrite it, you also need to carry out the symbol along with your term. So that's why I took the negative 10, or the negative with the 10. So then let's see, the next highest term is going to be the 5v to the 9th, and it's positive, followed by 7v to the 3rd. The negative 8v squared minus 4v. And there you have standard form. This one doesn't have a constant, but if we were identifying the degree would be 11, and then the leading coefficient, I'll just call that LC, is going to be negative 10. All right, so there's no constant because our lowest degree is 1, not 0. So then adding and subtracting polynomials, I just kind of combine them all in this one example. Just be wary of distribution and then also making sure that you distribute any negative signs to every value inside of your quantity. And then at the end, just make sure that you write your final answer in standard form. So here we have a negative outside of the second quantity. When you distribute this, keep in mind that you can actually drop the parentheses around the quantity. And then this one doesn't have anything on the outside, so I'm just going to let it be 5x to the 3rd minus 7x squared minus 3. And then I'm going to go ahead and distribute this negative inside the second quantity. So we're going to have negative 3x to the 3rd minus 2x squared plus x minus 8. And then here really we have a positive 1 on the outside, which isn't going to switch the signs on the inside of the second, or I guess the third quantity here. So really you can just drop the parentheses. 5x squared minus 4. All right. Next thing when you go about this, I kind of like to identify the similar terms. So anything with an x to the 3rd, I'm going to combine. I think that's it. So let's see, 5 plus 2 minus 3, 7. Whoops, minus 3 is 4. X to the 3rd. Anything with x squared, I'm going to combine. We have 7 and 2, which are both negative, and then a positive 5x squared, which is going to leave us with negative 4x squared. Any x terms right here, so plus x. And then our constant terms, we're going to have negative 3 plus negative 8, which is negative 11, plus negative 4, giving us negative 15. And there you have it. It's in standard form. So that kind of takes care of polynomials in standard form and adding and subtracting them. Next thing that we're going to do is we're going to FOIL them. Foiling is where you multiply your polynomials. If you remember, we call it foiling because it tells us to go in order of first, outside, inside, and last. Okay. Actually, it gives you a nice smiley face if you do it right. Foiling is really just distribution with multiple terms. So if we follow the FOIL method, it's going to be first, so 2 times 3 is 6x to the third. Outside, you get 15x. Inside, negative 14x squared. And then last, negative 35? So just make sure your answer's in standard form. So I'm just going to have to switch out those middle terms. Sometimes you'll be able to add them if they have the same power, but in this case they don't. And if you go back over here, if you just put in 2 eyes, it kind of looks like a smiley face. Kind of cool. All right, so some special products, so some special foiling. Anytime we have the same terms with opposite signs, so here the U's are the same, the V's are the same, we have a different term or a different symbol on the inside. When you FOIL that out, you will always get the first term squared, so it'll be U squared minus V squared. So you can check this one out. Here we have X and X, which are the same, 2 and 2, which are also the same. But we have an opposite sign in the middle, so when you FOIL them out, you're just going to get the first term squared, which is x squared, minus the second term squared, which will be 4. Here we have a perfect quantity squared. Just a little side note, that's just kind of like having u plus v times u plus v. And then you could FOIL it from there. But anyway, the quick way to do this, or the quick FOILed format, is going to be the first term squared plus twice their product, so 2uv, plus the last term squared. So applying it to this, x plus 6 quantity squared, you're going to get x squared. 2 times 6 is 12, so it'll be plus 12x. And then 6 squared is 36, so plus 36. Here, u minus v, quantity squared, same idea, except for this middle term will be negative. So it's going to be u squared minus 2uv plus v squared. So when you go to FOIL this, it is just going to be x squared, and then 2 times 6 again is 12, so it'll be negative 12x plus 36. So you probably did a lot of practice with those last year. What we're doing again, we're going to maybe make our polynomials, or binomials, a little bit more complicated, which is fine. Sometimes you can use substitution to kind of simplify it so that you can see what special product you are going to do. For example, when you look at this first binomial, you have this x plus 1 as a whole quantity minus y. Now, I might not quite know how to go ahead and FOIL this, so instead of seeing it as x plus 1 minus y, I'm going to go ahead and substitute in n for x plus 1, all right? Just so I can see it a little bit better. So really, I'm just going to take x plus 1, and I'm just going to replace it so that instead of x plus 1, it says n. So here's what I would ask you if you were in class, which one it matches, 1, 2, or 3. It's going to go along with this last one right here. You can see that we have 2 terms with a negative to the second power. So if we use this format to FOIL it, it's going to become n squared minus 2ny plus y squared. Now that we've FOILed it, you can go ahead and substitute back in the quantity x plus 1 for every n that you use or that you see. So here this is going to become x plus 1 squared minus 2x plus 1 y plus y squared. You could leave it like this. I kind of like to keep the singletons right here in the middle together, so I'm going to rewrite it so that it is x plus 1 squared minus 2y x plus 1 plus y squared. Yes, you could go ahead and FOIL this, distribute all of that, but just to get practice with the standard, I guess we'll call them properties, I just want to show how to apply those properties to a little bit more complicated binomial. All right. Part B, here we're going to have a couple things going on. We have 3 binomials. What I would do is maybe look to see which ones look the same, see if you can figure out which of these properties you're going to use. If you look at the first two, we have this x plus y, x minus y, which kind of goes along with this u plus v, u minus v. I'm going to apply that property. So if you kind of follow it along, here this ended up being u squared minus v squared. So when you FOIL this out, it's going to become x squared minus y squared. And then you can drop down the second part. So now we're left with x squared minus y squared and x squared plus y squared. It's another situation where we have the same terms with opposite signs. So we're just going to do the first property all over again. So the first term squared is going to become x to the 4th, right? X squared squared. The second term squared, y squared squared is y to the 4th. And the property states that we have a negative on the inside. So there you go. This last part is a little bit, I guess, trickier to see which property you're going to use. What I would do is maybe identify anything that's the same in the first and last part. Okay. Both of these have an x plus z, and I'm going to use that substitution again, just so I can see it a little bit better. All right. I'm going to let n be x plus z. All right. So instead of having x plus z plus 6, I'm going to rewrite that so that it is n plus 6. And this is going to become n minus 6. And if you compare it to the properties up here, you might notice that we have the first property again. So when FOILing this, you're going to get n squared. What would that be, minus 36? All you have to do then is back substitute. So that means that here we have n squared. Just replace n with what it's equal to. And I would leave it in parentheses. So it's going to become x plus z squared minus 36. If you wanted to, you could go ahead and FOIL this all out using the second property. But just to get practice with identifying what property to use, we can stop here for now. All right, that's going to be the first part of the video. The second part, we're going to do factoring. So see you in a minute.